Hello, everyone. This lecture is on biodiversity and extinction. It's really important for us to understand biodiversity as a concept, how the complex web of life fits together, and how this impacts our access to natural resources. As you can see here, there's a whole bunch of species that are actually going extinct. Um, I have a picture of the monarch butterfly, which a couple of years ago we were very concerned because its numbers were very low. And then somehow over the last year or two, it's kind of bounced back and we're really still worried that it's going to fall really low. And well, monarchs might be pretty, they're also really important for the ecosystem. All three of these animals are on the verge of extinction. We know that polar bears are also having some serious issues. This is the golden toad. It's on the verge of extinction. So these are all animals that are on the verge of going extinct. So to understand biodiversity, we have to understand some specific terms. So first is genetic diversity, how things are diverse within a species. Each individual is, each grouping is a distinct population with unique genetic makeup within the species. We can't have agriculture without genetic diversity. We know that inbreeding is incredibly bad for any species. And as populations shrink, the genetic pool is actually shrinking as well. So the odds of creating genetic abnormalities increases. So genetic diversity is really important. When there's a loss of diversity, it makes the population / species more vulnerable to extinction. So a species is the level at which there's great diversity on life. And this is the species level is also where we tend to do a lot of our conservation focus. We have an Endangered Species Act. That's because our conservation efforts are focused on the species level. But really these species that we are focusing on tends to be an indicator for the overall health of a system. So when we look in an ecosystem we're thinking about saving, we're looking at the species level, but that species is the ecosystem, is a representative of the ecosystem that we're trying to save, kind of the canary in the coal mine. And of course, an ecosystem is the living and non-living organization that interacts with each other within a specific place. We are often interested in the trophic interaction. That's the transfer of energy across an ecosystem, from prey to predator, from plant to grazer. So how energy passes across a system. Ecosystems need to be functioning properly in order to have life. When an ecosystem is not functioning properly, we see a decline in life. And so this is part of the reason why when we think through conservation, it's really the ecosystem we're saving, but we're doing it through saving a species. So species diversity, we know of about 1.75 million species, but we're pretty sure that is a real undercounting of how many species there are. We estimate there's about 30 million species, but realistically, it's probably 5 to 15 million. But even so, we've only really understood a fraction of that. And the vast majority of the global diversity actually occurs in the tropics. So the tropics is our primary life area. We don't have a lot of species as we get into colder climates. So as you go towards the poles, we see a decline in actual species. So for global diversity, and this is kind of a map of global diversity, and really you can see here the number of species is biggest in these red areas, right? So this is where we have the largest global diversity. This is the Amazon rainforest. This is part of Africa. This is in Southeast Asia. Right here's India. You can see we have a lot of diversity in these areas. Here's Latin America. But you can see as we go to the poles, very low species diversity because there just isn't a lot of energy sources up there, right? When we think in terms of the tropic relationship, we usually go from plant on land, we go from plant to grazer to prey, well, there just isn't a lot of plants up here all year round. So that makes it much harder in order for species to survive up there because there's such a low amount of plant life to support the system. And here's another look at global biodiversity, species number of vascular plants. Plants are important. We need plants. And so this gives you a feel. You can see very high concentrations of vascular plant diversity. Again, in the same places, we see a lot of diversity overall. And then when we get up into these top areas, we see very low. This is the desert, right? There's not a lot of anything in the desert. But here's all North Africa. This is the Middle East. This is around the Mongolian desert. This is actually the Andes Mountains, which is very low species diversity as well. And then, of course, the Arctic. And then, of course, we didn't even talk about the Antarctic because there's like not many species at all. There's some penguins and a couple plant species, and that's it. In order to keep life on the planet and life healthy and everything rolling the way it's supposed to, we need species diversity. And when species start to go extinct, we can see that the ecosystem is in crisis. So, talking a little bit about species. So we have this thing called an indicator species. An indicator species are those that we think are good indicators on species health within ecosystem. So they're an indicator species. They indicate the health of the ecosystem. Now, we've been studying extinction for a bit now, and we figured out kind of the natural rate of extinction. Extinction is a natural process. Species come and go, right? So species evolve and species go extinct depending upon changes in their ecosystem and access to a whole bunch of things. We expect the natural rate to be about one species every 400 years. So that's kind of slow extinction rate. And these are of the species we know. Remember, I said we only know about 1.75 million species, and we estimate there's between 5 and 15 million species on the planet. So we can look at this extinction rate, and we can do this through archaeology and paleontology and stuff like that. You can see that we have a pretty steady extinction rate, and then we start to get into the Industrial Revolution, and that's when we start to see this dramatic increase in extinction over time. So right now, the extinction rate is 113 times the natural rate. New Zealand alone has lost 60 species. That's huge. That's not one every 400 years. That's like, it's only been like 200 years. So that's significantly higher than what we should be doing in terms of the background rate, which indicates, for example, New Zealand has a problem with their ecosystem. Humans, the answer is humans. Humans are the cause of a lot of extinctions. We know that most of the megafauna and megaflora that used to exist, their extinction was caused heavily by the influence of humans. There was some environmental shifts that happened, but mammoths and saber-toothed tigers and things like that, humans hunted them. And so that really pushed them towards extinction. As I've mentioned before, there's been 5 mass extinction events that we know of. So the first one happened about 440 million years ago. There's 2 main phases to this event, the glaciation and a heat event. And then we have the late Devian extinction event about 365 million years ago. The Permian Triassic event, which this was a volcano in Siberia. The Triassic Jurassic event, that we saw 201 million years ago. This is part of our dinosaur event. This isn't the dinosaur event. The Cretaceous Paleogenic extinction was the dinosaurs. We think that's the asteroid that hit in the Yucatan Peninsula. And this is ours, yay us. This is the anthropogenic, the Holocene event. And this is heavily being influenced by the use of fossil fuels in the environment. And feel free to pause the presentation and be able to read this. All right, so how do we assess the risk of extinction? So we estimate the risk of extinction from conservation biologists who collect species level data. Some really exciting and interesting work going on in this area, especially around citizen scientists helping to collect information. So you can actually participate in data collection as a citizen science around species conservation if you wanted to get involved in that. There's a lot of really interesting work that's being done. Right now, species conservationists have evaluated about 70,000 species, and they're looking, and this is how they rate them. So you should go to zoos. Zoos are cool places. Most zoos, in their information about each animal, will have this information on the placard about the animals in the enclosure. So either we have deficient data, we're not very concerned, vulnerable, endangered, critically endangered, regionally extinct, extinct in the wild, which means they only exist in zoos, and extinct all the way. So some examples of extinct all the way, the dodo bird, right? We know that's a human extinction. We hunted the dodo bird to extinction. The black rhino is actually extinct in the wild. The only place it exists in zoos, and even that is pretty small populations. And there's just no way for us to have a big enough breeding population to be able to reintroduce this into the wild. So in many ways, this species is functionally extinct. Koala bears actually were endangered or vulnerable, but there were some really major wildfires that happened in Australia a couple years ago, and that actually shifted the koala bear up this chart. We know that some regions, the fires were so bad that it actually killed off all the koalas. Again, we're seeing a decline in species diversity. So breeding koalas to be able to reintroduce them back into the wild areas is going to be very difficult. It's going to take a while for those areas to actually recover. And because koalas only exist in one place, that's in Australia, in certain parts of Australia, they're really in this critically endangered area. So right now, about 13% of all birds, 41% of all amphibians. We watch amphibians because amphibians are particularly vulnerable to toxins in the environment because they absorb water and nutrients, not nutrients, but they absorb water through their skin. So if they're in a toxic environment and an extinction event in that area because of toxins can wipe out the amphibian population. So we watch amphibians a lot. Mammals are actually pretty easy to watch. They tend to be really obvious and bigger, and yeah, they migrate, but their migration is usually in large herds. And then of course, reptiles, about 20% of all reptile species are endangered as well. So a regional breakdown of threats to biodiversity. So these are the 5 major areas that we consider when we're thinking through biodiversity. And hippo, habitat destruction, invasive species, pollution, population, and overexploitation. These are how we kind of think through this threat. Hippo, habitat destruction, invasive species, pollution, population, and overexploitation. So you can see the number one threat is changes in land and sea use. No matter where you look, that's it. That's what's destruction of habitat, turning that into human involved areas, whether that's the growth of towns and cities, the use of extraction industries, changing that habitat over to farming. That change in land and sea use has a huge impact on threats to biodiversity. Species overexploitation. overfishing, overhunting, the extinction of top predators, that comes into this. And then invasive species. When you shift the land use and you've actually declined the balance of the ecosystem, it makes it much more vulnerable to invasive species. Pollution. You can see in Latin and the Caribbean, pollution's not as big of an issue as it is in, say, North America. This is Canada, the United States, and Mexico, or Europe and Central Asia. And then finally, climate change. So in Latin and Caribbean, almost 13% of threats to biodiversity are related to climate change, which is more than double compared to other regions for now. As you know, California is having its 20th year of drought, and we're going to see massive increases in heat blooms. This shift in climate change is actually going to start to ramp up in terms of how much this is going to cause regional threats to biodiversity. So we know climate change is shifting in terms of how destructive it's going to be. And part of this shift is because of how we see the world. Historically, we see the world through an anthropocentric view, where humans are at the top. We are somehow outside of this web, and the things that are most important to us are what get prioritized. So this is what is valuable to humans: technology, money, our own pets. Yes, I'm aware that this is a man. Women are secondary in most of the world. They're considered property still in a lot of places. Even here in America, you're only going to be making about 84 cents on the dollar compared to a man. And so, yes, you're not as important. Women are more likely to be in poverty, more likely to have health issues, more likely to have all these systemic issues. And that's because what's valuable to humans. And of course, this is called also an instrumental value, this anthropocentric view. And then on the other hand, we have a cosmocentric view. Notice that humans are in this. We are not in what's at the center is the earth and saving the planet. I know people like to say save the earth, but I got to tell you something. Earth is going to figure this out just fine. Earth has been through these extinction events before, recovered. Life has made it back. What's not going to make it are the species that are here now. So we need to be saving the humans and the frogs and the trees if we want to make it through climate change. And that comes with shifting our values and views from an instrumental anthropocentric value to an intrinsic biocentric cosmocentrism view, which is things are valued for their sake of existence. Things are valued because they're important in their ecosystem. They are helping that ecosystem stay healthy and survive. And remember, that includes both living and non-living things. The idea that each species has an inherent right to exist. If we view each species' right to exist as equal to our own, it shifts how we engage with ecosystems. And cultures and communities that have this value actually have healthier ecosystems. Yes, they're being affected by global climate change that's being caused by those that have an instrumental value, but their ecosystems are going to be healthier. They're going to be more robust and resilient, and they're going to be better at adapting. So, and that's that ecocentric view. Focus on the ecosystem more than its components, as opposed to a biocentric view, which is the value of each species for their own sake. So ecocentric is viewing the collective together as a valuable resource because of its existence. And this brings us to notions of eco-justice. So the idea that everybody has a right, an inalienable right, a human right, not even just human right, a right to have access to basic fundamental life-giving properties. We talked about those different spheres of existence, the biosphere, the hydrosphere, that those spheres have a right as well. So the notions of eco-justice, which are the conditions or principle of being just or equitable with respect to ecological sustainability and protection of the environment, and also how that is linked to social and economic issues. So people who often get included, well, things who get included. So people, when we talk about eco-justice, we're often talking about how people are, how the impacts of the environmental issues are unequally distributed across populations. We know that people that are least likely to be contributing to climate change are most likely to suffer from its consequences. And those who are the largest contributors to climate change are least likely to suffer from its impacts because they have the ability to get out and find other means for themselves. The impact on the animal kingdom. I don't just mean like lions and tigers and bears here. I also mean, everything in the animal kingdom. And we can even think that is larger. That should also include the plant kingdom. We need plants. We need plants for medicine, for food, for everything, right? For sequestering carbon back into the soils. That plants do that really well. And this idea of eco-justice for nature in general. And this is something that's just being really discussed in terms of the idea of justice around the world, but especially in the United States, the rights of nature to exist. And there's actually a whole lot of legal fights that are going on around the rights of nature. And there is actually a Nature Bill of Rights that has been proposed both in the United States as well as globally. Because when we think in terms of human decisions around resource management, we have prioritized ourselves and our wealth over the rights of everything else. And so that's being called into question today, especially as we start to see really major environmental shifts that are going to have catastrophic impacts on nature. And we're part of nature. So it's really important as we go through this class, you keep in mind that it's the reality of where we exist is here. We do not exist outside the ecosystem that we live in. We are a fundamental part of that ecosystem, and protecting that ecosystem actually leads to protecting ourselves. So that's the lecture on biodiversity, and I hope you have a wonderful day.